All right, we just heard about the properties of a magnetic pickup coil, how a wheel speed sensor should operate. Let's take that information and go to the vehicle. I've got a new wheel speed sensor here, got a DVOM down below, and on the vehicle, of course, then we have the wheel speed sensor that's hid in behind of the brake rotor. But instead of trying to gain access that way, I can reach up on the frame, literally unplug the weather pack connector on that, and back probe, or front probe in this case, the two actual wheel speed sensors. One, we want to take and measure the resistance of this wheel speed sensor. And so we are on resistance, we are on ohms down below here. And you can see that the resistance is 1.018. And the manufacturer does call for anything from 1 to 1.3 on this, so the resistance is there. The coil of wire is not broken, and so on there. Next, what we're going to do though is we're going to spin the wheel and we're going to measure the AC voltage on this guy. So I'm going to take my meter, turning back, AC volts, and then we'll do a min-max, record, and then I actually have a ratchet set up on the wheel, and we would like to spin this guy at approximately 1 revolution per second on that. So reaching out for maximum leverage, I just stuck a lug nut back on it, and I spin this 1001, 1002, 1003, 1004, 1005. Out of that, that should have generated an AC voltage, enough of an AC voltage out of that to compare it to the all data specifications or manufacturers. And in this case on this, if we come down and look at our actual meter, you're going to see 229 millivolts on that. Let's check out our minimum and our maximum. Minimum's 227, maximum's 229. Those two numbers equal each other, telling us it is of a sinusoidal wave. They are equal. It's just a typical waveform on that. But in all data, it said at 1 revolution I should have 350 millivolts at least. You know, who's at fault? This gets to the point that you're going to be a little intimidated and say, well, what's right, what's wrong? What I've done over here is just chucked up a new one into place, and we're going to take our meter and we're going to connect it to our new one and compare it to an older one on there. Turn the meter off, out to reset, hook up my 2 leads to my volt DVOM. We remember that it was 1.1 ohms resistance on the other one. Get some backlighting, and we got the 1.019, which the resistance value is equal to the old wheel speed sensor. So the resistance on the old one is the same as on a new one. At this point though, what we're going to do is go in and I'm going to spin this one the same way that I did, 1 revolution per second, so that way I know the speed is close to being the same on that. And we're going to measure the voltage on this by doing an AC min-max on him, off, volts, backlight, min, record. And at this case, if I go 1001, 1002, 1003, 1004, and away we go. And if we look at our voltage now on this in millivolts, we actually have about 1,000 more volts out of this unit there then, or 1,000 more millivolts on it. So with that, that's showing how much more voltage the original one had, or the new one has, versus the old one, even though the wires are good, no corrosion on the terminal. We have an extra air gap at the end of the wheel speed sensor versus the tone wheel on that. To get the wheel speed sensor out, you're probably going to break it. Then how long before the wheel bearing goes bad? Maybe we should just replace the whole unit.